Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Hoping to find you in good health. Hopefully, you are taking all the precautionary measures in order to stay safe and have already set a proper study routine. If not, then do it as soon as possible. Do it now, because now is the high time. Kindly prioritize your tasks in your daily routine. Your first priority should be your studies at any cost. Dear students, today we are going to study topic number 2 of chapter number 1, which is types of an operating system based on working and functionality of an operating system. There are basically 9 types of an operating system, differentiating in their functionality, namely batch processing operating system, multi-programming operating system, multitasking operating system, time-sharing operating system, real-time operating system, multi-processor operating system, parallel processing operating system, distributed operating system, and ninth and last type is embedded operating system. In today's class, we will cover the first 4 types of an operating system. Before moving towards the types of an operating system, let's have some glimpses of the past lecture. We studied the introduction of an operating system. An operating system acts as an interface between a computer user and a computer hardware. You can see in this side-by diagram that operating system lies between the hardware. At hardware level, you can see there exists a CPU, microprocessor, RAM, input-output devices, and storage devices. And software includes any type of application softwares like MS Word, MS Excel, and any other types of system softwares like device drivers, utility programs, and language processors. So an operating system of a device makes interaction possible between the programs, files, application softwares being used by the user and the hardware components. If you eliminate an operating system from a device, the user would not be able to interact his stuff with the hardware. Commonly used operating systems are DOS, all versions of Windows operating system, Macintosh operating system, Linux and Unix operating systems, which are mostly used on servers. You can search for Android and iOS operating systems by your own self. Take it as an assignment. An operating system performs all the basic tasks like file management, memory management, process management of a device. It also handles input and output devices and controls all peripheral devices like all types of drives and printers. Firmware loads an operating system from hard disk into RAM. Firmware resides in ROM or BIOS chip, and that ROM or BIOS chip is basically attached on a motherboard. Firmware gets activated when a computer is switched on. Operating system also provides security to the system or device. It controls network operations and settings, detects hardware failures too. So, coming back to our today's topic, types of an operating system. The first type we are beginning with is number 1, batch operating system. As its name indicates, something is to do with a batch or a group. A batch operating system is a software which combines together same type of jobs or tasks in batches or groups. And after making the groups of same tasks, this operating system executes these tasks one by one in a sequence. If we deconstruct this definition, points to understand are, number 1, this operating system groups together multiple jobs, multiple tasks, or multiple processes. Number 2, this operating system groups together same type of jobs, same type of tasks only in a group. Number 3, after combining same type of tasks together in a batch or in a group, this operating system automatically executes them one by one. This means that if one batch or group is being executed and that batch has 10 similar tasks grouped inside it, the operating system will start the execution from the first task till the 10th and last task in a sequence, one after the other gets executed. Question arises is, what does execution mean? Execution of tasks or programs or jobs is always performed by the CPU or by your microprocessor. CPU, when fetches the program's data and instructions from RAM, that data and instructions become processes waiting for their execution inside the RAM. CPU applies an instruction on the data. This is called as execution or processing of that data. Execution is done by the CPU but controlled and monitored by the operating system. CPU applies instructions chosen by the user on the data in order to perform execution. As you can see in this diagram that there are 6 jobs or 6 tasks loaded into RAM temporarily. Batch operating system allows the CPU to fetch tasks or jobs along with instructions from RAM. Batch operating system first arranges similar tasks into one batch or into one group. For example, job 1 and job 2 have same nature, so batch operating system arranges them in batch 1. Job 3 and job 4 have got same type or same nature, so batch operating system places them in batch 2 all together. Job 5 and job 6 or job have got the same nature, so batch operating system places them in batch 3. Now, all the jobs or tasks or programs having same nature are grouped together in same batch by the batch operating system. Afterwards begins the duty of a CPU. CPU would apply instructions on task 1 or job 1 present in batch 1, executes that task. After that, CPU applies instruction on task 2 or job 2 of batch 1. Means CPU executes the jobs inside a batch one by one in a sequence. Likewise, CPU executes the job 1 or job 2 of batch 2 one after the other. Then job 1 and job 2 of batch 3. This process continues till the execution of last task in last batch. The diagram being displayed on the screen also shows the same concept that user performs certain tasks using a program. Those tasks or jobs are being handled by the operating system in a way that the batch operating system combines together same type of jobs only in batches or groups. These batches are then executed or processed by the CPU or microprocessor of a computer. Here I give you an example of banking system. Suppose a bank has 100 customers or 100 account holders. That bank prints financial statements at the end of a month for every account holder. A bank has 100 customers or account holders. That bank prints financial statements at the end of a month for every account holder. A bank financial statement tells that how many or how much transactions or money withdrawals or money transfers have been done from a customer's account. So, a bank wants to, number 1, issue financial statements at the end of a month for each account holder. Number 2, bank wants to issue ATM cards to the new account holders. Number 3, a bank wants to issue credit cards to old account holders. As bank's server or bank's central computer on which batch operating system is installed, that server will carefully examine the nature of tasks being assigned to it. Three types of tasks have been assigned to a server, which are: number one, server's batch operating system has been assigned the task of generating financial statements for 100 account holders. Number two, server has been assigned the task of generating details for issuing ATM cards to new account holders, as there are only 10 new account holders out of 100. It also has been assigned the task of generating details for issuing credit cards to the old customers, to the old account holders, and there are around 20 old account holders who don't have credit cards. So, batch operating system first groups those 100 customers or 100 account holders on a server computer and then applies same instructions or options on those 100 account holders. That instruction or option is, for example, let's say print financial statement. It has already grouped 100 account holders in a batch or group, so the batch operating system will apply the same task on each account holder, one by one in a sequence, from first account holder till the 100th one, and executes automatically. A batch operating system can easily and efficiently print each account holder's financial statement one by one. It performs the same type of instructions on all jobs or tasks present in a batch in the sequence in which they appear. It provides an easy and efficient way of processing same type of jobs. Batch operating system then groups only 10 new account holders in a group or batch. It now applies the same instruction, that is, generating details for issuing ATM cards one by one in a sequence from first account holder to the 10th and last one. Along with implementation of same instruction on all account holders, CPU executes side by side all the tasks or jobs in a batch. Afterwards, batch operating system similarly groups only 20 old account holders in a batch or in a group, applies the instruction, and executes the tasks or jobs in a sequence. Second type of operating system is multi-programming operating system. A multi-programming operating system is a software that loads one or more programs in main memory RAM, stores these programs in RAM temporarily, and executes them using a single CPU. As you know, dear students, RAM only stores currently active programs being in use. If you open any file or folder or program or software, it will first of all load it into RAM by multi-programming operating system, which keeps them loaded into RAM for longer periods of time and afterwards allows the CPU to execute these tasks, jobs, and programs. The concept of multi-programming is solely based on the ability of the computer to store programs, data, or instructions for a longer period of time to reduce CPU idle time or to reduce CPU spare time. Means this operating system has the ability to load multiple programs in RAM and keeps them loaded. But question to ponder upon is that why multi-programming operating system will keep programs loaded into RAM? Answer could be to reduce CPU's idle time or spare time. But Another reason to keep programs loaded into RAM is that CPU would be able to grab or fetch any program loaded into RAM. CPU would execute the program's data and instructions after fetching them from RAM. If 5 programs are loaded into the RAM, multi-programming operating system keeps them loaded into RAM until the CPU fetches programs from RAM and executes them. CPU fetches one program from RAM at a time, executes it, then moves back to RAM, fetches second program from RAM, executes it, then fetches third program from RAM and executes it. Likewise, CPU continues with fetching and executing back and forth from RAM. You can see that clearly in this diagram. If user is giving an input to a computer, data or input directly loads into RAM. If user opens an already existing program from hard disk memory, it also gets loaded into RAM. In both cases, CPU fetches data from RAM, executes it, processes it. After processing, data gets stored inside some permanent storage space. So, concept to grasp is basically that, as we say, multi-programming operating system loads programs data into RAM, but also performs the execution of one or more programs using a single CPU. As CPU performs execution of programs or tasks or jobs or processes in nanoseconds. Remember that a nanosecond is 1/1000th of a second. So, due to CPU's execution speed in nanoseconds, it looks like to a user that a computer is performing execution or fetching or loading of programs at the same time or simultaneously. We, as human beings, cannot fathom or judge a computer's execution speed. We cannot catch up with that speed. Reality is that, in fact, CPU or processor executes only one program at a time. It executes multiple programs, but not at the same time, only one at a time. When one program is being executed by the CPU, the other programs wait in the queue for their turn. In multi-programming operating system, when one program is busy with input or output operation, the CPU executes another program in queue. Queue means a waiting list, a priority list of tasks. Example, when CPU grabs or fetches programs or data or instructions from RAM, multi-programming operating system creates a waiting list or queue of programs loaded into RAM. In this queue, operating system arranges all programs, data and instructions on first come, first serve basis. Program which was loaded into RAM by the multi-programming operating system before any other program will get first priority or first place in the queue. Program which was loaded by the multi-programming operating system into RAM secondly after first program will get second priority or second place in the queue. Program which was loaded thirdly after first and second program will get third priority or third position in the queue, and the process goes on. So, important concept here is why queue or waiting list has been developed. Actually, it is done in order to prioritize tasks for CPU's execution. CPU fetches a program, task or job from queue placed at first position. makes it a process by loading it into CPU buffer or register, and then executes this process. When some program, task, or job from the RAM's queue or waiting list gets loaded into the CPU buffer or register for execution, it becomes a process. Each process then gets executed finally by the CPU. Each process belongs to a different program. So all the queued programs or waiting list programs have now become processes when got placed into CPU's buffer or register. CPU is utilized to create multiple ready-to-run processes. When a program becomes a process, it is now ready for execution by the CPU. The process which was at first place or got first priority in queue before being loaded into CPU's buffer would be executed first by the CPU. The process which got second place in the queue would be executed after the first process. The process which got third place in the queue would wait for the CPU to complete process 2 execution. Afterwards, CPU performs process 3 execution. The process which got fourth place in the queue or priority list would wait for the CPU to complete process 3 execution. Afterwards, CPU performs process 4 execution and so on. Essence is multiple jobs or tasks or programs loaded into RAM are queued or prioritized by the multi-programming operating system in a queue or priority list inside the RAM. All jobs are then executed by the CPU on first come, first serve basis. The job which comes first into the queue will get first place. Likewise, all jobs will be queued waiting for the CPU. When CPU attends or executes a job or task till its execution, other jobs wait for the CPU to get free. In this diagram, you can see job A and job B are busy with other operations, while job C is waiting for the CPU as CPU is busy executing job D. So CPU executes all the queued tasks, jobs, while they are simultaneously or at the same time stay loaded into the RAM by the multi-programming operating system and got executed by the CPU not at the same time, but looks like that execution takes place at the same time of all programs as CPU switches from one program to other, executes one program, then the second, then the third program. This concept is called as context switching. CONTEXT. Context switching means CPU switches from one type of program or job to another type of program or job for execution, but CPU keeps in view the priority of task or job. Multi-programming operating system utilizes a computer's resources to improve the performance of that computer. Resources like CPU's buffer, CPU's time, RAM's space, other permanent storage devices, memories, input-output devices, etc. Multi-programming operating system shares these resources among all the programs or jobs or tasks of a system. As jobs, tasks loaded into the RAM utilize RAM's space, they utilize CPU's time, utilize storage devices space after the execution by the CPU. Dear students, third type of an operating system is multitasking operating system. It is an operating system which performs multiple tasks at the same time on a computer using a single CPU. Multiprogramming means multiple programs or jobs are kept loaded into the RAM at the same time, as well as handled by the CPU at the same time through context switching, while multitasking is just a rudimentary form of multiprogramming used in a different context, or you can say that multitasking is an extension of multiprogramming. In multitasking, multiple programs are split into parts or subtasks or sub-jobs, means each program or task or job is further divided into subparts. CPU executes multiple parts or tasks of multiple programs at a time by switching back and forth among them. For example, operating system loads 3 programs into RAM from memory, which are MS Word, as user wants to create some electronic documents in this software. Multitasking operating system also loads a movie into RAM as user has started downloading a movie along with working on MS Word software. This operating system also loads a song as user has started listening to a playlist of songs along with working on MS Word software. This shows user is performing 3 tasks or 3 programs simultaneously, means at the same time. User applies multiple instructions or uses multiple options on these 3 programs, which means that these programs would be executed by the CPU by applying multiple instructions on them. Whenever CPU applies an instruction on one program, it would create a subtask, means dealing of one program by applying an instruction on it would create a subpart or subtask of that program. When CPU applies another instruction on that same program, that would create another subpart or subtask of that program. So this happens with all the programs as multiple instructions are associated or applied on these programs. Coming back to our example, as 3 programs got loaded into RAM simultaneously at the same time, for example, MS Word, movie downloading, music playlist. Suppose every program was applied with 3 instructions each. So for every program, 3 subprograms or subtasks have been created. Single CPU allowed by the multitasking operating system would fetch part of one program from queue. Remember that as all programs, their data and instructions are loaded into RAM, multitasking operating system creates a queue, a priority list or waiting list for programs and subprograms or subtasks. So that CPU fetches each subtask or subprogram from queue one by one and executes them. Here you can see that part 1 of program 1 gets loaded into queue at first place because users started working on program 1, part 1 before any other program or part. So CPU fetches part 1 of program 1 and executes it. After that, CPU fetches part 1 of program 3 for execution because it has got second place in priority queue. As user started working on part 1 of program 3, user applied an instruction on program 3 after working on program 1. So that's why CPU executed part 1 of program 3 after execution of part 1 of program 1. Afterwards, as part 1 of program 2 got loaded on third place inside RAM's queue, so CPU executes it. Part 2 of program 2 was loaded by the multitasking operating system at 4th place in queue and is still waiting for the CPU, which is busy with execution of part 1 of program 2. So after its execution, when CPU gets free, it executes program 2 part 2. Means every part of every program will be executed in the sequence in which they got loaded into RAM or RAM's queue. Another reminder, before execution, every part of every program will be converted into a process by the CPU. As there is only one CPU present, so CPU gives an impression of executing these programs and subparts of these programs simultaneously, as execution is being performed in nanoseconds, so it looks like to a user that execution is happening at the same time of all the programs, but in reality CPU performs execution of each task separately one by one. All in all, essence is CPU first executes a part of MS Word program, then switches to execution of a part of music playlist, then again switches to execution of a part of downloading movie, then switches to execution of second part of music playlist, then switches to the execution of second part of MS Word, then to second part of movie download, until the execution of last part of last program happens. CPU continuously switches back and forth between programs and their subparts. This is the concept of multitasking by a single microprocessor or CPU. Multitasking is able to keep track of where you are in these tasks, as user also goes from one program to other while working on them. This operating system also maintains the data or information written in these programs or generated by these programs. Multitasking operating system gives an impression of parallelism, as CPU performs execution of tasks at such high speed in nanoseconds that it looks like to a user that CPU is performing execution of multiple tasks parallelly at the same time or simultaneously. Now we will discuss the differences between multiprogramming and multitasking operating system. First difference is that multiple programs, tasks, or processes remain loaded into the RAM concurrently using a single CPU or microprocessor with the help of multiprogramming operating system, while a multitasking operating system allows multiple programs, their subprograms, subtasks, or subparts to get executed concurrently, simultaneously at the same time using a single CPU or processor. The second difference is multiprogramming operating system keeps loaded or running several programs using a single CPU, while multitasking operating system keeps executing several tasks along with their subtasks sharing a common resource, for example CPU or a single CPU. Third difference between multiprogramming and multitasking operating systems would be that multiprogramming operating system utilizes a single CPU or a single processor, while multitasking operating system can utilize a single as well as multiple processors or CPUs for execution. Fourth difference is that multiprogramming operating system uses context switching. As I've already told you, when CPU switches from one type of program to another different type of program, this switching is called as context switching, while multitasking operating system uses a back and forth switching. Next difference is that multi-programming operating system takes more time to perform tasks, while multitasking operating system takes less time to perform tasks. Multi-programming operating system presents the idea of reducing CPU's idle time or reducing CPU's spare time, while multitasking operating system presents the idea of dividing a task, a program or job into subtasks or into subparts. Multiprogramming is based on the concept of storing programs or tasks for longer periods of time in RAM, while multitasking is based solely on the concept of assigning time slice or quantum to every program, process, task for separate execution. Dear students, fourth type of an operating system is time sharing operating system, which is a software that shares the CPU time between multiple programs that are loaded in main memory RAM. This concept is actually related to multiprogramming as well as multitasking. How? It will be made clear in a while. When CPU executes multiple tasks or subtasks of a program through multitasking using back and forth switching, or when CPU executes or loads multiple programs through multiple programming using context switching, CPU is in fact sharing its time among multiple programs. In case of multiprogramming, it gives a time slot or time slice to every program, then executes every program according to the allotted time slice one by one. In case of multitasking, CPU shares its time among multiple subtasks or subparts of multiple programs. It assigns them with time slice or time slots, executes every subtask or subpart according to allotted time duration separately. These time slices or time slots shared by the CPU are called as quantums, since the CPU switches between programs, subprograms, tasks, subtasks at extremely fast speed. All the processes or programs get the impression of having their own separate CPU for execution. Time-sharing operating system enables many people located at various locations, located at various terminals or nodes to use a particular computer system at the same time. That particular computer system can be a server or central computer of a network, which can share its resources like its processors or its CPUs, its CPU time, its memory, its input-output devices like printers or scanners, its RAM, etc., with client computers or connected nodes. Take the example of a of a supercomputer or of a mainframe computer, which can be used as a server in huge networks, as mainframe has got thousands of CPUs or processors installed inside it, so it can deal with the requests of thousands of connected users inside a network. Multiple client computers or users can request for servers resources, and multiple clients can share these resources among them at the same time. Resources like CPU or memory, etc., etc. A time-sharing operating system allows many users client computers to share computer resources simultaneously. Suppose in a network, 3 client computers request from the server for their program's execution. Server first loads the programs coming from client's memories into its RAM, prepares a priority queue along with dividing these programs into subprograms or subtasks or subparts by applying instructions on them. After that, server's time-sharing operating system shares its CPU time among multiple programs and subprograms. CPU then assigns a time slice or quantum to each subpart or subtask of a client program. Let's say CPU assigned 9 nanoseconds to subpart 1 of client number 1 program for execution. CPU assigned 2 nanoseconds to subpart 2 of client number 1 program. CPU assigned 15 nanoseconds to subpart 3 of client number 1 program. CPU assigned time slice of 7 nanoseconds to part 1 of client 2 program for execution. Then again, CPU assigned 3 nanoseconds, respectively 10 nanoseconds, 5 nanoseconds, 2 nanoseconds, 1 nanosecond to different parts of client 2 and client 3 programs. CPU of a server assigned these time slices or quantums to different parts of different programs of different clients, because CPU will execute these programs or subparts of programs as per allotted time slices. If a CPU is assigned 7 nanoseconds to a subtask, this means that subpart will be processed or executed by the CPU for only 7 nanoseconds. Even if the execution of that subpart doesn't complete in 7 nanoseconds by the CPU, doesn't matter, because after 7 nanoseconds, CPU moves or switches to next subpart for execution as per its time slice. CPU will complete the execution of that part having 7 nanoseconds afterwards by allotting it a new quantum. Another case can be like that. As we know, a mainframe server has thousands of processors or CPUs working parallelly inside it. So, if 3 client computers are requesting to get their programs execution done by the server, server will divide the programs of 3 client computers among its multiple processors or multiple CPUs. For example, server's time-sharing operating system divides 3 programs of 3 clients into 9 subparts or 9 subtasks. Operating system now assigns each subtask or one subpart to separate CPU, means now 9 CPUs or 9 microprocessors of a server using time-sharing operating system have got 9 subtasks each. One CPU or microprocessor of a server handles one subtask. Every CPU assigns a time slot or quantum to its subtask. All 9 CPUs would be able to execute these 9 subtasks simultaneously by sharing time. That execution or processing would be faster as multiple CPUs are involved. Time slice or quantum allocated by the mainframe CPU to one client program would expire after its utilization or after its deadline. When it expires, the control gets passed to the next user's task on the system. Again, you can suppose that 3 computers are sending their tasks for execution to server's CPUs. Server assigns one or more than one CPUs to 3 tasks coming from clients. Suppose it assigns only one CPU to 3 tasks. CPU then in that case allots time slices or quantums to all 3 tasks. CPU executes every task according to the time slice limit. If first task was allotted 2 nanoseconds quantum by the server's CPU to computer number 1 task for execution, CPU will exactly work on that task for 2 nanoseconds. When time slice limit expires, the control of time sharing operating system gets passed to the next task. CPU executes next task as per its quantum limit. When tasks deals every task. When tasks quantum expires, CPU switches to next task for execution. CPU deals every task as per time slice or quantum limit or quantum duration. This is how time-sharing operating systems work on servers, as servers have hundreds and thousands of processors or CPUs inside them working or executing tasks parallelly at the same time. So time sharing actually makes the execution process faster for clients. But time sharing operating systems can work on normal or common personal computers too. Every operating system either installed on a single CPU computer or installed on Core i3, Core i5 or Core i7 having 3 or 5 or 7 processors respectively. So time sharing operating system can be installed on any of these processors or CPU based computers, but the computers having more CPUs or processors would be able to handle multiple programs or multiple tasks or multiple subtasks by assigning quantums at the same time. That's why we say time sharing operating systems commonly being used on mini computers and mainframes, because these computers can act as servers, and by using time sharing operating system they can attend or execute or support hundreds and thousands of users simultaneously in big organizations such as airlines, banks, and universities, etc. Now, we will talk about the differences which exist between time sharing and multitasking operating system. First difference is that time sharing operating system allows execution of multiple programs or tasks or processes or multiple subtasks of a program simultaneously using multiprogramming as well as multitasking, while multitasking operating system allows execution of multiple programs or tasks or processes or multiple subparts of a program simultaneously using only multiprogramming. Second difference is time sharing operating system can be used on a server which serves multiple clients simultaneously, so that it can serve unlimited or several or numerous or multiple programs at the same time. Multitasking operating system can be used on a personal computer which serves multiple programs simultaneously. Time-sharing operating system utilizes thousands of CPUs or processors for execution, while multitasking operating system utilizes single or multiple CPU or processor on single core or dual core or Core i3 or on Core i7 computers for execution. Time-sharing operating system keeps executing several programs of several computers sharing a common resource, that is CPU. It shares its CPUs among them, if I talk about a server, while multitasking operating system keeps executing several programs of one computer sharing a common resource like CPU among them. Time sharing operating system allows execution of programs of multiple nodes of multiple clients at a time, while multitasking operating system allows execution of multiple programs of only one computer at a time. Time-sharing operating system allows sharing of resources among multiple programs of multiple computers at a time, while multitasking operating system allows sharing of resources like CPU, RAM, permanent storage devices. So it allows sharing of resources among multiple programs of a single computer at a time. Time-sharing operating system executes multiple parts of multiple programs of multiple clients simultaneously at the same time. This concept connects time-sharing operating system with multi-programming and multitasking, while multitasking operating system executes multiple parts of multiple programs of only one and same computer simultaneously. This concept connects multitasking operating system with multi-programming. So dear students, this is the end of our today's lecture. You can see and listen to this lecture repeatedly on your portal as well as on our college's YouTube channel. Keep that in mind that majority of the concepts are not available in your book, so you should write down each and every concept in your class notebook. Okay ji, may Allah bless you. Stay safe, stay healthy. Allah Hafiz till next lecture. Thank you.